All right, guys, welcome back. Here's another quick little video to help you out for the second derivative. So the first derivative pretty much gives you max and mins for the most part. Second derivative talks about concavity. So if the second derivative of the function is positive, that means that the function is concave up. Concave up means it's going to hold water. If it's concave down, it's going to look like this. So critical point is when the first derivative equals 0 or is undefined. A possible point of inflection is when the second derivative equals 0. Possible point of inflection is when the second derivative equals 0. And why I say possible is the second derivative must change signs in order for it to be a point of inflection. So if I come down here and look at this graph, so if this is the graph of, I believe, the function, okay, so if you look here, from here, the function is increasing, which of course we know if the function is increasing, its derivative, its slope of the tangent line is positive. So that's why we have the first derivative is positive. The second derivative, in this case, if you look right here, it's not holding water, that's concave down, which means the second derivative is negative, it's less than 0. That point of inflection is right here. That's when it's going to change from concave down to concave up. Always just think of that spot as being halfway between the max and the min, or vice versa. If you look at that, it's like halfway between the maximum and the minimum here. So second derivative gives you those points of inflection. It's only a point of inflection, again, if it changes concavity or if the second derivative changes signs. So again, if we look at this little part over here, f is increasing, the function, this is the graph of the function is increasing. That means the slope of the tangent line is positive. First derivative is positive. In this case, it's holding water, it's concave up, so the second derivative is positive. Okay, now if you think about the function, if the function is increasing, its derivative is positive. So if I say that the first derivative is increasing, that means its derivative is positive, meaning if the second derivative is positive, the function is concave up. So now we're going to be talking about the derivative increasing and decreasing. So you have to pay attention. Are we talking about the function increasing, telling us that its derivative is positive, or are we talking about the derivative increasing or decreasing, telling us something about the second derivative, which is going to give us concavity? Okay, so you really got to be careful here, and you really have to think. So if I go through this example here with you, we have a closed interval. So if we were talking about absolutes, we'd be making our t-chart and doing the whole thing with the endpoints. Let's see if that comes up. All right, so the first question is, find the x-coordinate of each point where the graph of f has a point of inflection. There is only going to be a point of inflection when the second derivative changes signs. Second derivative changing signs, but this is not the graph of the second derivative, it's the graph of the first derivative. So if I'm thinking about the first derivative increasing, its derivative would be positive. If the first derivative is decreasing, then its derivative would be negative, meaning second derivative. So since this is the graph of the derivative, we are looking to see when does the derivative change from increasing to decreasing, or vice versa, because when that is changing, if the derivative changes from increasing to decreasing, that means that the second derivative is changing from positive to negative, which creates a point of inflection. Okay, so let that soak in a little bit. So that's why in this case, I can talk about the second derivative changing signs, but the problem is we don't have any information about the second derivative. We only have the first derivative. So a point of inflection will occur. F, the function f, will have a point of inflection when the derivative changes from increasing to decreasing or decreasing to increasing. So let's follow this graph. This is the derivative. I'm decreasing, I'm decreasing, I'm decreasing. So right there, the first derivative is decreasing, which means the second derivative is negative, which actually would tell us that the function is concave down. Then right here at -1, the derivative changes to increasing. That means -1 is a point of inflection. It's changing from, at -1, it's changing from decreasing to increasing. Then at 1, the derivative is changing from increasing to decreasing, which means x equal to 1 is a point of inflection. The second derivative is changing signs. And then again at 4, it's changing from decreasing to increasing. This is the graph of the derivative. You really have to pay attention to that. Okay, so now it's saying when is the function concave up? Don't look at this graph and say, oh, where is it holding water? No, this is the graph of the derivative. So we want to know when is the function concave up. The function is concave up when the second derivative is positive. The second derivative is positive when the first derivative is increasing. Okay? So where is this function increasing? On these intervals. So again, you can look at that. Number 3 is asking for when the function is concave down, which means the second derivative is negative. We don't know what's going on with the second derivative. We know it's the first derivative has to be decreasing. So that's why these reasons are here. Take note, justify your answer. Justify your answer. You will not get points on the AP exam if you don't justify your answer. Okay, and we have to use the information we're given. We're given the first derivative, so our justification has to be using the first derivative. So same idea again down here. Pay attention. What is this the graph of? It is the graph of the derivative. The graph of the derivative. So we're going to have to use those to explain and justify. So number 1 says, where does it f? Where does the function have a minimum? The function has a minimum either when the function changes from decreasing to increasing. Well, we don't know because this is not the graph of the function. So I need to think about when is the derivative changing from negative to positive. And again, negative means below the x-axis, positive means above the x-axis. So if I just follow this graph, I'm above, I'm a below. Actually, that point would be a maximum because the derivative just went from positive to negative. I'm looking for a minimum, so I want to know when is this graph changing from below to above, right there at 3. So that's the answer for number 1. There's number 2. We're looking for that maximum, so we're looking for where the derivative changes from above to below. So right there at -5, and then again at 7. It changes from above to below. On what intervals is the function increasing? The function is increasing when its derivative is positive. So this is the graph of the derivative. We're looking for where is it positive? Where is it above the x-axis? And then the opposite for when we want it decreasing, that's when its derivative is negative. So think about that on the graph. Point of inflection. Point of inflection occurs when the second derivative changes signs, meaning from positive to negative or negative to positive. However, this is the graph of the derivative, so that's when the first derivative will change from increasing to decreasing or decreasing to increasing. When the derivative is increasing, that means the second derivative is positive. So on and so on. So that's what's happening there. You can kind of look at that, let it soak up a little bit. And remember, point of inflection is when the second derivative changes sign. So yeah, I talked about that. Number 5, we're looking for f to be concave up. Again, that means the second derivative has to be positive, which means the first derivative has to be increasing. Hopefully you're starting to get this, starting to soak in a little bit with the differences of that. And then same thing with number 6. So then the next part here, you're actually given a function. You're not given a graph. So that's where the number lines are going to be helpful. To find out where f has a max or a min, it goes to the first derivative. First derivative gives you max and mins. When the first derivative is positive, I would say, so this is talking about the first derivative, function is down here. Function changes from increasing to decreasing. First derivative changes from positive to negative, that's going to be a max. Which if I just literally draw the graph here, function is going from increasing to decreasing, keeps decreasing, and then increases. Take note right here at 0, the first derivative does not change signs, so there is not a max or a min there. Once you have that number line up there, you can totally find out where f is increasing and decreasing by what I just talked about. Number 3, it gets into the points of inflection. Points of inflection occur when the second derivative changes signs. Second derivative. Points of inflection come from the second derivative. Max and mins come from the first derivative. Keep that straight. So hopefully you can follow that and understand. And then number 2, or this whole problem here, gets into you're given the derivative of g, writing an equation. We need 2 things, a point and a slope. Point comes from the original. You're taking 1, plugging it into the original function f. Oh yeah, that was given to us right up there. The slope comes from the derivative of f at 1, which we were given there. You're just writing the equation. Take note here, read carefully on that. Number 3, of course, you've got some product rule in there. There's some stuff going on. Make sure you can follow that to get the derivative. If you have questions on that, let me know. Continue to answer those questions. Okay, and then in addition to this, you've got the golden rules. Golden rules are just all of this reiterated. So read, really think about what's going on there, check those answers, and let us know if you have questions. Oh, I want to come back to this part right here, this part here. This is telling us if the first derivative is 0, where is the first derivative 0? That means the slope of the tangent line is horizontal. It's going to happen either at a max or at a min like that. So this is saying the derivative is equal to 0. If it's concave down, that creates a max. That's like number 2. If it's concave up and the derivative, the slope of the tangent line is 0, that creates a minimum. So that's number 1. If the second derivative is 0, we don't know what's happening. We don't know if it's concave up or concave down, so we don't know anything about a max or a min on that. Okay, so this is kind of a rare case where you're using the fact that the first derivative is 0 and then looking at the second derivative to find out if it's a max or a min, but that comes into play also on the AP exam. All right, hope everyone is staying safe and taking care of themselves.